So here we are in Quarry Hills. Don't worry, the sign is actually bent. It's, someone's knocked it over. So what are we looking at here? We're looking at the Granodiorite. And on the path here, there's lots of basalt that they've gotten from some other place. So here we have the neighbourhood. Granodiorite goes around not quite to that Coles over there supermarket. That is Hornfels, which is metamorphic, and the Granodiorite continues underground. So this bathylift is quite extensive. Hope this microphone works pretty well. And this is I think it's a conservation area. So we've got some wattle, got some, can't remember what plant that is. It has yellow flowers. Grevillea, Cassinia, that's one of my favourite plants. Because I've got lots of eucalypts. And I can smell the wattle. It smells very beautiful. So here is the Granodiorite. As you can see, it's covered in moss, lichen, and it has like a smooth surface with onion feel. So this has been peeling off. And here's some she oak. She oak, it's like a pine. It's not actually a pine, but it's like a pine. It has fine. So these are actual branches. They're not leaves. The leaves are very small and in between. So in essence, that plant doesn't have any leaves. And you walk over here. Here we have some of the Granodiorite. So on the geological maps, this is classed as a basalt, especially on the older ones. I'm not basalt, classed as a granite. And if we look closely, so this is the weathered surface. You can see a lot of the quartz. So this is plagioclase, the white one. The quartz is the grey. And in between you have finer matrix of probably hornblende, which makes it a little bit dirtier or darker. But that seems to erode a lot easier than the plagioclase or the quartz. So this is pretty much not Granodiorite anymore. It's an altered surface. And here we have a lot fresher Granodiorite. You can see it has large phenocryst. I wish I could. And here looks like we have some. Is that biotite? I lost it. There we go. Yeah, it looks like brownish colour. So biotite. If it was black, it would be muscovite, but it looks like biotite mica. And so this whole outcrop used to be capped with hornfels, so metamorphic hornfels. So this intruded into the Silurian Devonian rock, and that was about 350 million years ago. So this rock is, so the sedimentary rock around it is older. And as we go up the hill, we'll be able to see it a lot better. So here's some more of the Granodiorite. It looks a lot fresher, but still eroded. Not as eroded as the other outcrop that we saw before. Oops. Yeah, and you've got to be careful with snakes around here. But snakes don't worry me. They're quite nice, interesting. And this has been outcropping for quite a while. And you can see here, this is very eroded. So this is pretty much soil. If you can break it in your hand, so we can see. You can see the black crystals. They look like a muscovite mica, and looks like a lot of the rest of the quartz. The feldspars are pretty much degraded, and as you can see, a lot of the iron looks like it's been released because it is a red colour. Beautiful. And here we have some more eroded. This is very eroded. And here's another one in my hand. So, break in half. You can see the muscovite seems to not be eroded quite easily. So, a lot of the feldspar is broken down, so it's a hornblende in quartz. Sparkly, sparkly. So maybe that mica is a secondary mineral. Okay, and as you can see, the thing about the erosion, so as it gets eroded and weathered, it forms a soil which, because of the vegetation, does stay here quite easily. And so it does, basically just covers the batholith, so you can see here. So we have the granodiorite, and this is all used to be granodiorite, it's now turned into soil. So this is a nice excursion. Look, young plant coming up. Some more. So when this erodes, it has an onion peel. It's just because there is a crystal structure, but each of these minerals has a different crystal structure. It's just the external extent of erosion is pretty even across the whole lot, so it erodes evenly. When you've got a sedimentary rock, you usually have different layers that have different hardnesses, and so sedimentary rock erodes at different rates depending on the type of rock. But this is all pretty much has a similar composition all around, so it should erode at the surface at the same rate for each of the minerals. So as we saw before, the mica seems to last longer, biotite muscovite micas, and the feldspars seem to erode a lot quicker. So let's see if we can find, there was a larger outcrop up here. I think this used to be a quarry. That's why it's called Quarry Hills, where they would have extracted the rock, probably for gardens or whatever. So here we have some fresh rock, and we have large crystals of neoplagiate clays, smaller crystals of hornblende, and the grey crystals of quartz are quite large as well, but not as extensive. So this is about, I think it's about 65 to 90% sodium and calcium feldspar, and it's about 20% quartz. That's why you don't see as much quartz. And it's only about, oh, it has minor, it looks like probably the black crystals are only probably about 70%, so that's the hornblende, probably amphibole. Then you got about 13-40% mica, but they're in smaller crystals. And so when we go up the hill, this batholith, the portion that's been exposed at the surface is quite small. So this is probably only like a square kilometre of surface area. And then we have probably 4 or 5 square kilometres of the metamorphic rock. So the hornfels, which surrounds the rock and it caps the rock. And the hornfels is over there, so over in that hill is, okay, oh, it's a bit hard to control this thing. So over there we have another hill. That is hornfels, because it's only this hill that is the Granodiorite. And the hornfels has been eroded away. So, you know, in the last 65 million years, this all used to be the mountain range covered in the Dargol Formation. So that's been eroded, and the Dargol Formation no longer exists here. And this batholith, which has been here for 350 million years, is slowly being exposed at the surface. So, over the time, in the next 10-20 million years, a lot of the hornfels and the Dargol Formation is going to be eroded from here, and more of this batholith is going to be exposed. So, eventually, this will just all be batholith. This portion of batholith will also be eroded, so we'll go deeper down into the surface. And how much? 12 minutes. Oh, getting a bit tired. So here we have some more rock. You can see, I might take that home. Let's go back to the path. It's a lot easier to walk on. And also get large boulders that have been eroded out of the hill. A lot of them probably have rolled down from the top. Meat pies. Hello. Magpies. These are the birds that swoop on your head if you go near their nest. Only about 30% of magpies do that though. Most of them don't. But if you look at them while they're swooping, it's less likely they will hit trying to attack you. And if we have a look, you can see Melbourne. There's Melbourne there. Quite a big city. Obviously I can see pollution there. So I'm in the northern part of Melbourne. This is where Quarry Hills is. You can see the Granodiorite, beautiful rock. So I'm actually still getting used to this gimbal. I seem to just push it down to the ground, so all you're looking at is the path. So here we have the actual quarries down there, and I just gotta catch my breath. So as you can see, that's all flat down there, that's basalt. So that's about 1 to 2 million year old basalt lava. And obviously this is the hill, so it didn't flow up here. Nor was this part of a caldera of some sort. You can see it's pretty flat all the way out. Till you get to the city, you need to go around up north. So over that way is mountainous, and that way's flat because there's also, it's not too flat, it's actually quite undulating, but it has a lot of floodplains. It's also, there's a lot of the Dargol formation as well. And here we have a Granodiorite outcrop. As you can see, people walk over this, it gets worn quite easily. Okay. So this looks like it's pretty fresh. Well, it's not too fresh, but you can see the amphibole. Then you got the quartz. So let's zoom in. Okay, where's my finger? Okay, you got a lot of quartz there. It's a large, looks like off-white crystals. The white is the plagioclase. Then the hornblende is dark colour, and the dark colour is also the micas as well. So that's quite a, unless you can do a chemical analysis, you can't really tell the percentage exactly, but as I said, probably about 17% is amphibole or hornblende, most likely, and most of the rest of the ground mass. So it's only about 30% dark crystals, and it's about 70% light crystals. It actually looks nice in relief. So we're pretty much at the top of the outcrop. So there is another exposure over that way of Granodiorite, but most of that hill is the hornfels. And I'm not too sure if you can see the hornfels here. Will be very interesting. And here's some more of the old quarry. Okay, so here we can see a lot easier. And you can see in between the valley they've actually put all the houses, and that's on top of the hornfels. I can't see any outcrop on the other side, so I think over that way is where the other outcrop is. And up here is hornfels, but also on the other side is the Dargol Formation. So that's also farmland as well. I mean, the farmland is on the other side of the hill, and this side is the conservation park, and it goes around here. Here we have, over that way is King Lake. So it's not likely we're seeing any of the hornfowls. I reckon that's probably just covered in the soil and sediment, which is really just a pity. So I think that's it for this part of the video. And if I see any hornfowls, I add up at the end of this section.